Okay, project management. As you watch the video, the building, whatever, right? Kinda something. When we say a project, many tasks and jobs, works related. And then the time is very important because many works are related. And then when we say project management, management activities, video said manage people, equipment, material, and so on to make maybe faster and then cheaper too. So managing project activities or tasks to make it better and faster, cheaper. So that is project management. And in the video, it says critical path. Critical path means the longest task like in a line. So manage that critical path. If tasks in a critical path delay, then the entire project delay. So schedule and plan activities in a critical path carefully. So we use the critical path method managing project time. And also in video, it says something do first and then next like that. So for example, before digging the ground, they need like a survey of the ground, what under the ground is like a sewer system and electric line system. So after survey the ground and then dig, and then before that maybe they have the design of the structure and so on. So we call we can say there is a sequence of activities, something first and then next and so on. So types of the critical path method, single time is made, critical path method, 3 activity time is made, critical path method, and then time cost model of the critical path method. Time cost model, another name is PERT. PERT stands for performance, review, and so PERT stands for performance, evaluation, and review technique. So many cases, many times in project management, we call PERT and CPM, PERT and CPM technique. So that is time management technique for project management. And first, the critical path method with a single time is made. If we know certain activity time or task time. We know the activity time. Then we use a single time estimate. So using this critical path method, we can determine time estimate for the project, the total time, completion time. Example. This example has 7 activities or tasks. Then each activity has like a designation, A, B, C, D, E, F, G. And then each activity has immediate predecessor. Activity A doesn't have an immediate predecessor. That means in this project, activity A is starting point. And then there is a sequence. After A finish, then B can start. So B, activity B's immediate predecessor is A. That means after A finish, then B can start. And then C can start after B, and D and F start after C finish. And then F after D and E, G after F. And then each activities or task time like this. So using this information, we can draw network diagram. So activity A starts, and then B after A. So using node and arrow, you can draw network diagram like this. So based on immediate predecessor, and then times in parentheses. And then early start time and early finish time. So A starting point, so start 0 and then finish week 2 because A needed 2 weeks. After A finish, then B start right away. Then right after 2 plus 1, 3, 3, 4, 4, 6, 4, 9. And then this one, activity D, task D, finish in 6 weeks, but this one still works. So wait until activity E finish, then after F can start. So starting point is 9 and 14, 14 and 15. So early start time and early finish time. Then late start and late finish. Calculate late start, late finish from right side and then go backward. 15, 1 minus 1, so 14, 14 minus 5 is 9, and 9, 9 minus 2 is 4. And then when go backwards, if there are 2 or more late start times, then earlier one goes there, and then minus 1, 3, 3, 2, 2, 0. Why we need an early start, early finish, and late start, late finish to get slack. Slack is the time each activity can be delayed without delaying the entire project. Slack is late start minus early start, or late finish minus early finish. So activity D, 7 minus 4, 9 minus 6, 3 weeks of slack. That means I will draw timeline. Okay, timeline. Okay, duration is 15, and starting point is 0. And let's divide 5 and 10. Activity A, start 0 and finish 2, A, 2, 0. Then B starts 2 and finish 3, B and 3. And C starts 3 and finish 4. And D start 4 and finish 6. And then E, activity E starts 4 and then finish 9. And F starts, after finish E, then F starts 9 and finish 14. Then G, finish 15. Activity D, start week 4, activity D. Then it needs 2 weeks. So if the start in week 4, then finish week 6. If D start week 5 and then finish 7, 6 and 8, 7 and 9. If it start in 8, then finish 10. But activity F start at 9 because E finished week 9. So as long as activity D finish by week 9, then F can start without delay. So activity D has 7 minus 4 or 9 minus 6, 30 weeks of kind of spare time. So activity D has some flexible time, but combination is like this. So among start times and finish times, 4, 5, 6, 7, 4 is early start, 7 is late finish, late start, 6 is early finish, and 9 is late finish. But others, the same, 0, 0, 2, 2, 2, 2, 3, 3, like this. So activity A, B, C, E, F, G, they don't have the slack, 0 slack. That means if activity delay, then entire project delay. Activity B delay, then entire. But this one can be delayed up to 3 weeks. So in this project, and in project network, there are 2 possible paths. One is here, this path, and the other one is this path. So on first path, A, B, C, D, FG, at least one activity, if at least one activity in the path has slack, then that path is not critical. But this path, all activities doesn't have any slack. So on this path, any activity delay, then entire project delay. So there are two possible paths. This path is critical, and then all activities are critical activities. Only this one, non-critical activity. So in project management, schedule carefully these activities because they are critical. And then critical path, length, duration is, there are two possible paths. No, first one is A, B, C, D, and F, G. So add all activity times plus 2 plus 1 plus 1 plus 2 plus 5 and 1 equals 12. And the other path, A, B, C, E, F, G, 2 plus 1 plus 1 plus 5, another 5, and 1 equals 15. So critical path is longest path among the possible passes in network. So this one is critical path, and then duration of project is the same as critical path duration. So this is critical path's duration and project time. So critical path is A, B, C, E, F, G, and duration is 15. Okay. If we have one certain time, activity time, then we use that one single time, single activity time estimate. But in real world, activity time is not certain, usually uncertain. That means sometimes we schedule, then sometimes it finish early. And then like average time, and then sometimes delay, finish late because of whatever reason, like weather reason, and the part come delay and so on like that. So time is not uncertain. So even we have an activity time using the activity times and then get project time, that time is not certain. So we can get probability information using this one. Okay, another example. And then there are 3 activity times, A, M, B. A is optimistic time, finish early. And then most likely time is kind of average time. And then pessimistic time is delay or late and finish time. So using this expected time formula, we can get like a single time using a formula, and 3 activity times, we can get single time, such as a single time. So using that formula, expected time for activity A equals A is 10 plus 4 times 22 plus B, pessimistic time is 28, divided by 6. This one is constant because the coefficient of this one is 1, 4, 1. So 1 plus 4 plus 1 is 6. So this is kind of weighted average. So equals this one. So using formula, we can get expected time for each activity. Then we can follow steps such the same step of the single activity time estimation. Draw work diagram, and then early start, early finish, late start, late finish. So we can get, we determine which one is the critical path using early start, early finish, late start, late finish, or like earlier I did, among possible paths in the network, then add all activity times, and then the longest is critical path. So in this network, there are 3 possible paths. So first one is this way, A, B, D, E, and G. That is now 21 plus 4 plus 2 plus 5 plus 2 equals 20, 34. Then next possible path is this one. So A, B, D, F, and G. That is 21 plus 4 plus 2 plus 8 plus 2 equals 37. And the last possible path is this one. So A, C, F, and G. 21 plus 7 plus 8 plus 2, that is 38. So 34, 37, 38, this one is longest. So ACFG is longest than critical path. And project time is 38, the same as critical path's duration. And those times, activity times, are not certain. It's kind of expected time. So anytime it can be short, it can be a delay, and so on. So 38, the duration, project time, expected project time. is not certain, kind of a probability. So in normal distribution, the expected time is 38. So it can be, it can finish early and it can finish late. Then the question is probability of completing the project in 35. So 35 is here. And then in, so this area. So it can be 35, it can be 34, and so on. So find this area probability. So using formula, Z equals D minus T. D is desired completion time, that is 35, and minus T, expected time, project time, 38, divided by square root of sum of variance on critical path. Variance on critical path. We need the variance, and variance equals B minus A. B is pessimistic time, optimistic time. So B minus A divided by 6 and square root, square. So using the formula, we can calculate variance activity A equals B is 28 minus A 10 divided by 6 and square equals 18 divided by 6 square equals 3 square equals 9. So 9 is variance of activity A. So using this formula, we can get all variances for activities. And then the formula Z-score formula, sum of variance on critical path. So add not all, just variances on critical path. Critical path is A, C, F, G. So add only 9, 2.78, 0.11, and 0. So D is 35. Expected time is 38. And square root. Variance on critical path. 9 plus 2.78 plus 0.11 plus 0 equals minus 3 divided by square root of 11.89 equals negative 3 divided by 3.45. Result is negative minus 0.869, approximately negative 0.87. This Z-score means on normal distribution, it is 38 and then 35 here. This is kind of mean average. Z-score on average point is 0, and then left side is negative Z-score, and right side is positive Z-score. So z-score is counted kind of the boundary. So this z-score is negative 0.87. So using this 0.85, we can find area from the chart. Negative 0.87 we cannot find negative 0.87, but it's between, oops, between 0.87 is between 0.9 and 0.85. It's like now 0.90, 0.985. So between 0.9 and 0.85, 0.86, 0.87, 0.88, 0.89. So 0.87 is closer to 0.85. So take 0.85, then the area, this area is now 0.19766. So answer is 19.76766%. So the probability of completing the project in 35 weeks is 19.766%. So we can get in, and then we may get probability longer than. So another question like this. The probability of completing the project longer than 40 weeks. This is normal distribution and 38 expected time, and then 40 here. So longer than 40, this area. So using the same formula, C equals desired 40 weeks minus 38 expected time, and then the same variance. So result is 0.58. So 0.58 is boundary. So 0.58 is between 0.55. So 0.58 is closer to 0.6. So take 0.72575. But the chart, normal distribution chart, give us left side. So here 38 and 40, and then z-score was 0.58. Then given area by the chart is left side here, but we need longer than this side. So we need calculation. One more calculation. Oops. One minus the given area equals 0.27425. So the probability that the project task takes longer than 40 weeks to be completed is 27.425%. Okay. This one is not in your lecture notes, but I just let you know what it is. PERT, CPM and PERT, difference between two, PERT and CPM. CPM, we have only time information. But if we have time and cost information about the project, then we can use this model, time cost model or PERT. So using the same technique, method, draw network diagram and then determine what is the project time. And then if we use more resource or machine or workers, then we may shorten the activity times and then project time, but we need more cost. So use more resource, make it shorter. That is, now we call that crash, C-R-A-S-H, crash. So this one, using this time cost model or PERT, we can get the crash information like this. Okay, there are 4 activities and then normal time and normal cost. So to finish in normal time, normal condition, 2 days. And then to finish in normal time, the cost is $6. But this one day, need $10 more. And then activity B, normal time, normal cost. To make it shorter, by 2 days, $18 crash cost, and so on. So using normal cost, normal time, normal cost, crash time, crash cost, we can determine which one is the most efficient project time. So first we draw, and then critical path is A, B, D. Then if we can, how can we manage and shorter any activity on critical path? Then project time shorter. So if we use another more resource on activity D, then total cost increase, but project time decrease. So using more resource, D again, more cost, shorter by 1 day. And then next on B, use more resource, cost more, but project time decrease. And then use A, more resource, more cost, but decrease, and so on. So step by step, then certain point, we use more resource, but project time didn't change. So stop there. So the shortest project time is 5 days. If we use more resource, so that is time cost model or PERT. Stop there. Even we use more resource, time doesn't change. So that is a time cost model and or PERT. In real world, for the project management, we use computer software, many computer software for the project management. Among them, in academic area, we use this most time Microsoft project. Marywood University doesn't have a project management course, but most school and then most business program, there is a project management course. When I worked at other school, then I taught project management course. Then at the time I used this Microsoft project. So Microsoft project looks like this. So given the activity information, then this program automatically draw a Gantt chart, and then also automatically draw network diagram, and then this one shows which path is critical. Just a moment, I will show you that program. Just a moment. Project management software here, and I will show you how it works. So using our first example, so here, task name, I will copy and paste. And then duration is 2 weeks. Then if we set start time like October 1st. So after type in information, this one draw Gantt chart. The next activity is write and submit. It takes 1 week. And then this one here, we need the predecessor information that is from A. So in this program, not ABC is the number. So 1 after 1. So after activity A or 1, next one start. And third activity is obtain approval. And it takes 1 week. B, so 2, third, fourth one. And 2 weeks. And then predecessor is 3. Next activity. Predecessor is 3. Next one. This one also 5 weeks. E and E, 4 and 5. Next one, last one, by assessment. Sorry, I lost network. So showing this one again. So after type in all information, then we can see Gantt chart like this. Then we can see network diagram like this. So there are 2 possible passes, and then the red one, this path is a critical path. I have this program, Microsoft project, but I cannot share this program because this one is kind of licensed. Just to show you how it works. So maybe at your work, if you need this kind of, if you are involved in any project, then if you need this kind of program, then you may ask your company, and then use this program. You can manage project activities. So on the video, you know, I'm not sure this one will work or not. If this one worked, then can watch. Yeah, this one worked.
No audio again.
No audio again?
No.
Come on.
Safe for work. Starting from about January through March, it was a real struggle. We're getting maybe 1 or 2 days of work a week where we can be up high, and it did lead to some delays on the project. I think we had at the peak probably 250 guys out there from all the different trades: ironwork, electrical, plumbing, concrete, every building trade imaginable was out there, and they were all out there together. And it was definitely 24 hours a day starting from about February onward. Maybe 200, 250 guys out in the field during the peak, you know, everybody going at once. Kind of a ballet of getting this guy out of the way and people standing there, you know, waiting for their turn to get into this area, and all pushing to try and get that opening day.
Flexibility is a critical issue for all project managers. The charts will help you track your progress, but you also have to be able to substitute tasks, labor, time, and materials in order to keep any project headed in the right direction. Despite all efforts to carefully control every element of a project, circumstances can interfere with the best laid plans. Kingda Ka ultimately took 16 months to complete and ran 10% over its original project budget. But the world's tallest, fastest roller coaster has been thrilling fans ever since it opened, and Six Flags is certainly pleased with its success. And Larry Chicola acknowledges that with each new project, he becomes a better project manager.
You know, you got to jump on your advantages when you have something that needs good weather and that weather comes, you know, get on it and do that and be ready. You know, be ready for that good weather, that break, because it might go bad on you again. It doesn't feel like it, but a week at the beginning is the same as a week at the end. It's still 7 days. It doesn't feel as tough at the beginning, right, because nobody's yelling and it's not time to open, but it's still a week, okay? So you could have done a week's worth of work at the beginning if you started a week earlier.
Careful planning, well-defined milestones, teamwork, and flexibility ensure success for managing any size project. Twists and turns in the schedule and in the completion of the tasks are inevitable. Delivering any project on time and on budget can be a challenge. When the project manager meets that challenge, it is worth celebrating.
You know, some projects are more planned out. Our jobs it's kind of fast and furious. You know, 15 months from start to finish of the world's tallest and fastest ride is a pretty good schedule. You know, actual construction time was only about 9 to 10 months, and that's fast. You know, I was pleased with how we were able to complete the job in the time we did.
Okay, good. Okay, that's all for today's what I prepare for project management. No assignment from this chapter. Instead, I will share something. Okay. here, this screen, okay. Then, when I was an MBA student, my school was like school's map looks like this, campus. And then there are not straight line. There are two entrances to the campus, and then it's oops. Do it again. Carefully. Straight line. Let me use my ruler. Let's say two doors entrance, and then here like street. Then traffic light here and traffic light here. And then many buildings inside there. The problem was the class finish, all classes start and then finish the same time. Like start at 4 and finish the same time. So all students to pass this gate and then enter the street. So many cars line up after finishing the class, and then many cars line up, and then after clear, then next class finish, and then cars line up and so on. Then this traffic light for this street longer, but for this entrance shorter. But busy time, many cars pass this on this street. But like when we the MBA class or the whatever class time finish, not many cars pass here. So there was the library building, and then I sit there. So I count on how many cars come, line up, how many cars now in a line, and then how many cars pass this street. So, and then this traffic lights capacity of this way, and then capacity of this way, calculate. So it was not my MBA class, the operations management, that this the same class final project I did. So I suggested two ways to solve this problem. So make this traffic light for this this way longer. Not all the time. Like when the class finish, then this light use a kind of computer program used like from 550 to 6 like 10 and 650 to 710. So and other time this way longer is okay, but when class finish, then traffic light the time control, then give this one solution, or the layout for a line here only one lane this way and this way, so make like make it wider, and then for this way make 2 lanes, then this capacity increase. So even though the same traffic light time, more cars can pass here. So make like a more room to car lineups. So increase capacity of this like a traffic light system. So I suggested 2 ways. Control this traffic light, and then make space, and then capacity increase. So this is operations management. So there is problem. Then using whatever technique or concept or change something, make it faster or make it better. Maybe make it cheaper too. So that is an operations management case. So I did this project for my final project for the class, and then I got an A. So many in our near our life, there are many operations management cases. So if you work, then maybe you can find something at your work. If they change something, then it can be better, or it can be cheaper, maybe better, cheaper, faster. Earlier semester, a student group brought that case. Our Marywood University, the building, the library building, inside there, there is the cafeteria. During lunch time and then during dinner time, long lineup. So some students complain about that. So to solve that problem, they suggested using like online order, and then increase the workers, hire only that time, use more workers, and then make it faster. So many things to solve that problem, longer lineup during that time. So that also a good operations management case. So by next, not class, next Tuesday, by next Tuesday, at least one individually, at least one possible operations management case. Just a topic. What is problem, and then how can you expect to solve a problem? So my case is like the school traffic system has problem, and then solution maybe change such, or add something like that. So think about it. So bring possible operations management case or cases individually, then we will discuss. So which from your work, from your near life, and then or if you know something problem, or if anywhere need improvement, then operations management perspective, then maybe that can be a better, cheaper, faster. So don't bring the big one. You know, certain student group previously brought Amazon.com case. That is already there. So, you know what, so far I show you the existing cases, and then I ask you to try to find the existing case from internet. So what they do, so we know what they do to make better, cheaper, faster. So now, what can we do? What can we do to make better, cheaper, faster? So find something, problem, or something area to improve. So don't bring the existing case or big one. So even it is a small thing, it can be good operations management case. So not next class, next week on Tuesday, we will discuss about your cases, and then which one is feasible, and decide, and then narrow down one or two, and then I will assign that or those case as your final project. Okay, question? Okay, that's all, and see you on Thursday.
Thank you. Have a good night.
Thank you. Good night.
Night.
Good night.